Alright, so
today we're simplifying radicals. So we take our exponent, our little exponent, and we're going to make it into our radical. So we're used to seeing our radicals like this, like our b right there. And so that is like a 2 right there. And that goes over to the exponent. Okay? And that also works on the opposite end of it too. So if a equals the square root of b, then a squared is equal to b. So you can kind of switch those. So on the examples, 5 squared is equal to 25. We already know the square root of 25 is 5. Okay. Now you have a powers chart, so you can see the 5th root and the 6th root or the 4th root. So the 5th root of 32 is the same is taking that 5. You can do it that way too. So it kind of works both ways.
Yes.
So do these with the calculator. You already know how to put this one into your calculator. You can do either 3 and then the math button. And then the inside. You guys know what the inside is called?
Foundation.
A foundation? Were we building a house or
Yeah, that's what we're building.
So the inside is the radicand.
Oh, I remember.
I know where the just put the extra notes in there.
Yeah. And then the 3 in front, or the 2, or the 5, that's the index. Okay, so put those in your calculator. Alright, so for the first one, yeah, for that first one, it's just second, and then the square, oh, not that one. Second, so you have your square root, 7.8. Try again. Square root of 7.8 is going to be 2.792, but we round to the nearest hundredth, so which spot are we looking at to round?
9.
9. Okay, so 2 is less than 5, so we keep it at a 9. So 2.79.
What do you think would happen if she clicked with the caret and then a 2?
It would be 7.8.
Whoa.
What about for the second one? I know we could have negatives under radicals.
What?
Because it's a cube.
It's a cube, so it's an odd index, so we can have our negative. It's set, or negative 1.5, 8, or 9.
9.
9, since 7 is greater than 5. And we can go backwards, so our answer to the cubed is our negative 4. Okay. And last one, math 5 of 99. 2.50.
1.
2.51. We take that to the 5th power, go back to 99. It goes back and forth. So on the last slide, when we took the square root of 7.8,
Yeah.
it only gave us one answer. But when we have a square root, isn't there a positive and a negative? We learned that in middle school or elementary school. So our calculator only gives us the principal root. So it's only giving us the positive root. Okay? So the principal root is what you would use in real life. So if you were using the distance formula and you had a square root of something, you wouldn't use a negative answer. You wouldn't have a negative answer. You can't go in negative distance. So the principal root is only the positive, but then if you have an odd index, you're going to have just 1. Okay? So you kind of read this. So if n is even and b is greater than 2, that's like our typical square root. You can think of that as kind of an example. So there's a positive root and a negative root. N is even and b, what's under the radical, so radicand, is less than 0. We did that with our quadratic formula, right? So that gives us our imaginary answers.
So let's do each of those examples. So on number 1, what's the square root of 4?
2.
2 and negative 2. Now what if we said only give us the primary root? What's your answer? 2. So if you have an even root, you're going to have 2 answers. And they're going to be real for number 1, is what that's saying.
Okay. And then number negative 2, so the 4th root of negative 16. So you have your chart. What's the 4th root of 16? So 4th, and you can go down to find 16.
65,000.
Or maybe it's 2. Okay? But 2 to the 4th gives us positive 16. How can we get that negative 16?
So
Okay? So you have to get the negative out front. That's how you get your I. And then 2 to
left and right.
the 4th is 16. Okay? Then, and it's odd if b is greater than 0, so I got cube roots. The cube root of 8 is
2.
2. That's just that one answer, that one root.
Right.
And then our last one, 3 to the negative 8.
-2.
Negative 2. Okay, try those 4 examples on your own.
So really quick, how many answers do you have for
So on number 4, the index is
2?
2. So that's even and greater than 0. So how many answers are we going to have? 2.
Even and greater than 0.
So positive and negative. 10.
Okay.
Okay. Then the index on number 5 is odd and greater than 0. So how many are we going to have?
1. It's going to be negative.
1 negative, right?
The
So,
radicand's less than 0.
right.
Is that what you're saying?
Yes, sorry. So negative 27 is less than 0. So we have our negative root. So negative 3.
The one answer, that's it. Negative 3, that's it.
Index is even with a positive radicand. So with our answer,
Plus or minus 5.
Plus or
plus
minus
or
5.
minus.
Plus or minus 5.
Okay, so you have 2 roots. Last one, index is odd.
Yeah.
So we're going to have one answer.
3.
And then that's greater than 0, so it's going to be positive.
Yeah.
So that matches the sign inside. And 3 is 3. Okay, Face got it. Yeah. Alright, we're gonna find a new way to do our radicals, or simplify it. So instead of doing dates to prom, there's kind of a quicker way. So we use the product property, which means if we have a radical, we can break it into 2 different ones. Now be careful, it doesn't mean that the square root of a plus b is the square root of a and b. Okay? Common mistake. That doesn't work. Okay? It's only when a and b are multiplied. So we took 75, and we can break it into things that we know will work out. So we know 25 times 3 is going to give us 75.
Yeah.
Okay? But this is a squared, right? It's one we recognize.
Right.
Now, is it just 5?
Square root of 3.
No.
Positive, negative, and then you have your square root of 3.
Right.
Okay? If you put it in your calculator, you should have square root of 75, 8.6-ish, and you do 5 square root of 3.
Different.
Those should match. And then that also works when you're dividing, too. So the quotient property says if you have a radicand that's a fraction, you can break it into 2 separate radicals. So this cube root of 8 over 27 turns into the cube root of 8 over the cube root of 27. which is a lot nicer to do than trying to find that decimal and take the cube root of it. Okay, so what's the cube root of 8?
2.
Cube root of 27?
3.
They're positive or negative?
Positive.
Just positive, since this is an odd root, there's only one answer. So side by side, we're going to kind of do both ways. We're going to do dates to prom, and then we're going to do our power chart method. So we'll start with our square root of 90. How would we do dates to prom? How would we break down 90?
So you can just do this above. This is not a place for this on your notes. Don't do it next to number 8 because you'll need the space for that. So just kind of do it up above.
30 and 3.
30 and 3, I heard.
10 and 3.
5 and 2.
No, 2 and 5.
Yeah.
Alright, guys. So those are all prime. So we have a pair of dates here. And then these guys stay home.
Boom.
So 3 square root.
You gotta grind some.
Yeah, exactly.
3 square root of 10. But if we did our power chart, so we have our square root of 90.
Yeah.
And then what perfect square can we break this into?
3.
So look in the squared column. Everyone, you have to use your power chart for this.
We're
Look at
looking
your squared column because it's a square root, right?
9 and
What is a perfect square that divides out of 90?
9.
9.
Okay. So that equals the square root of 9 times the square root of 10.
And 9 breaks into 3.
And that's just 3 square root of 10.
I feel like it takes me longer to find that thing.
Once you get used to it, it'll go quicker.
If you can memorize a lot of the perfect squares, it goes super fast. Like, for example, let me show you. Now, we teach you dates to prom and geometry because it's easy and you're young, but really the whole point of a square root is it square roots perfect squares, right?